There are many ways to measure how advanced a civilization is, by its feats of architecture, or art, or philosophy, or wisdom. How big and numerous their guns are probably is not the best measure of things, but they may make a very convincing case to those who feel otherwise. So welcome back to another Sci-Fi Sunday here on SFIA, where we explore the science behind science fiction and ask how realistic it is and what real science paths might allow a given sci-fi technology or something parallel. Today we'll be examining super weapons, from those just a bit stronger than we have now to those which might ruin worlds or even wreck whole universes, tearing at the fabric of space-time itself. We'll explore the weapons of the far future and those which might be used to attack your enemies in the past. And if that sounds like a fun topic, make sure to hit those like and subscribe buttons. Now, a problem we often have in science fiction is that a lot of the time, the weapons on display are actually a good deal weaker and less effective than modern ones. Frequently you'll see a show where they've got advanced lasers and phasers that are all high-tech, but weaker and less accurate than modern sidearms. There's also nothing between laser pistol and blow-up planet. Not much in terms of tanks and artillery, and even assault rifles and shoulder-mounted rocket launcher equivalents are pretty rare. In fairness to TV shows, with classic sci-fi TV shows, you're often working with limited budgets and trying to mimic the cowboy shoot-ups from westerns, but with lasers. If that's got existing audience appeal, it saves you money, and lots of actors, directors, and production crews would be experienced with making and filming that sort of scene already. So that's our acknowledgement that there are some real limitations on showing mid-range gear, but it nonetheless results in the bad guys way too often having their massive and overwhelming military demonstrated by "we have a doomsday device." On the other hand, that gives us a massive arsenal of doomsday devices to discuss today. As we did devote an entire episode to death rays already, we can skip around that specific class of weapon, and let's instead consider just bigger bombs than nukes for the moment. Though we should note that a superweapon need not be a singleton like a big bomb or gun, but it could be something like a self-replicating swarm of death bots, which we'll discuss later today, or just something very clever like a virus that makes everybody who catches it less aggressive, or the computer kind that deletes the secret bank accounts of everybody in power, or dumps their dirty laundry on public display. Now, in the classic film Dr. Strangelove, we find out the Soviets have a doomsday superbomb designed to go off automatically if they're attacked, but they didn't tell the other side, and the eponymous character chides the Soviet ambassador,
"Is that the whole point of the doomsday machine is lost? If you keep it a secret, why didn't you tell the world, eh?"
So there's always that question of why you would build a mega weapon, and whether or not a total lunatic is going to need other people help you on that project, any one of which could opt to be both greedy and self-protective by just leaving a vital component out. You have no real reason to keep such a thing secret, and since it is often hard to do so anyway, you can use weapon tests to demonstrate that you've got the mega weapon in question and that it does actually work. Why you want it definitely plays a role in which options you pursue, because a deterrence weapon needs to be safe to build and maintain and not accidentally set off, which means it needs failsafes and guardians, and those guardians now get a vote in whether it gets used and can potentially use it to threaten you too, if it comes time to be asking about pay raises and promotions, or changes in supreme leadership. Big bombs aren't cheap to build and maintain, but the real reason we never saw super nukes was because the hard part about building a bigger bomb is actually building a rocket able to deliver it, as otherwise you're detonating it in your own territory. The biggest nuke ever set off, the Tsar Bomba, was less than 50 megatons and honestly served little point. Often in history we find the world record for something big belongs less to a champion than a glorious example of why people can do bigger but choose not to. Any major power is capable of building a bomb that is as big or even bigger again. Without testing, it's hard to know if a new and bigger design will even work. After all, untested prototypes have a fairly bad track record for success, even when the design team has vast experience and resources, but there's nothing obviously tricky about boosting nuke size up more, and indeed bigger is generally more efficient when it comes to nukes or even reactors. But you hit a point of diminishing returns, as with big bombs being used on Earth, the loose rule is that if you double the yield, you only increase the radius of the explosion by about a third. Or more energy goes into making the mushroom cloud hotter, brighter, and taller. which looks awesome but is basically just further vaporizing what's already vaporized. And if that's not on a rocket, it's your homeland that's getting more vaporized. It's why an asteroid impact or volcano can have way more released energy than our entire Cold War nuclear stockpile and be thought of as fairly destructive but not be truly apocalyptic. Consider, 1 megaton bomb might kill almost everyone in a 2-mile or 3-kilometer radius, with few survivors and many dead out to about double that radius. But it would take about 8 megatons to double that radius, 4 miles or 6 kilometers, whereas an ICBM carrying several smaller warheads could deploy that as a cluster munition and get more damage done. Sci-fi is full of various bigger bombs than A-bombs and H-bombs, often something like the D-bomb or Omega bomb, and honestly it's not bad to have a bigger bomb, all things being equal, but several smaller ones with a combined equal or even lesser yield is generally more valuable. It's hard to estimate how much it would take to serve as a true doomsday weapon, as the asteroid impact we think killed off the dinosaurs was thought to be around 100 million megatons, or 2 million Tsar Bomba equivalents. Humanity would survive that, though most people might not, and a civilization might fall apart for several generations, which is nothing in the grand scheme of time or even humanity, but how much would kill us all off? And what would it take to just blow the planet up? I think to start our conversation of superweapons off, we would have to list modern weapons of mass destruction as essentially Category 1, and something able to wreck the whole observable universe as Category 10, though keeping in mind that we can envision multiverse-level weapons of destruction, so 10 is arbitrary, not maximum. I will semi-arbitrarily put anything that can wipe all life off the surface of a planet as Category 3, and actually obliterate a planet Death Star style as Category 4. Though exterminating an entire solar system in a classic space opera case of multiple inhabited planets and potentially hundreds of facilities on moons, asteroids, and other space habitats would be easier than obliterating an entire planet, as we will discuss in a second. An actual inhabited and developed star system really can survive a massive beating. The amount of energy needed to vaporize a planet the size and composition of your typical Earth-mass planet is going to be on order of 10 to 32 joules. But unless you are at war with the lava people living in the core, this is stupidly high overkill. Even just peeling the crust off the planet, which should take about 1% as much energy, should do the job. Indeed, we think a big rock hitting Earth in the deep past did exactly that and got us our moon. Though a single impact on one side of a planet might distribute energy to blow some mantle off there and leave crust elsewhere, I still have problems imagining anything surviving that. Though folks with spaceships on the other side of the planet might have some time to flee, depending on how fast the shockwaves travel. Ultimately, if you really want something dead, just remember the first rule of warfare: there is no such thing as overkill. It works well, and so does using multiple techniques. You blow everything up, gas the place, and then send in the mortar bots. Then you pave the smoldering embers over and build a giant monument to how vengeful you are toward your enemies, so that nobody else decides to poke their head up and take their chances at getting on your bad side. So something like 10 to 30 joules of energy, a million trillion joules, should do the job for any Earth-like planet. If you had to buy that energy in real modern dollars, at something like $1 for every 100 million joules, that's going to cost you $10 trillion, or more than the entire current global economy if it kept producing at current rates for the rest of Earth's lifetime till the sun roasted us. The assumption is that you have some cheaper or singular nuke-like power source with superweapons, but never forget that energy is originally and literally defined as the measurement of how much work you can get done. So, if you feel like you could get a lot better results in terms of net destruction by keeping modern humanity producing and working on a problem for a few billion years, then blowing all that energy on peeling the crust off a world isn't an effective use of juice. We see something like this with the Allied Cardassian and Romulan assault in Star Trek Deep Space Nine on what they thought was the enemy's homeworld, and they talk of how many hours they'll need to take off the crust and mantle. This does not seem the cleverest use of weapons, but then again it turns out to be a decoy planet and a trap. A megaton of nuke is cheaper as a power source, but again, those Cold War arsenals of hundreds, if not thousands of megatons of nukes would have barely scratched this planet's surface, just the life on it, and yet we're still talking generations worth of effort building those bombs, and trillions of cost in building and maintaining. Yes, vastly superior power production or automation might make such an object cheaper, but remember this will also apply to whoever was building the defenses for the place you want to attack. You need more like 100 trillion megatons of nukes to peel the crust off a planet like Earth, and 100 times that to vaporize one, though this varies a lot from world to world. In terms of antimatter, it would take roughly 1 trillion tons of antimatter to vaporize Earth, and several billion to remove the surface layer, but that feels a lot more plausible, assuming you have the ability to produce and store antimatter cheaply. Still a lot though, just to rip the crust off the world means having nearly a ton of antimatter per person living on it, and while we could have a real paradigm shift in cost and availability of antimatter, that would feel like killing someone by burying them under gold and diamonds. This can tempt folks toward using asteroids as a seemingly cheaper source of kinetic energy, and indeed it would be, especially if the space and math skills to find a big asteroid with very little delta V needed to change its course to an impact trajectory, but you can still assume that at best you're saving a couple orders of magnitude on energy cost, which is nothing to be sneezed at of course, but it's still a vast energy need, and there's nothing subtle about this massive use of energy. They're going to know you just shoved a giant asteroid off course, and the effort will be way more visible while ongoing than that asteroid by itself is. You might not care if they know, as they may be powerless to stop it, and the dread of inevitable death raining down upon them in a couple years might merely be sweet sauce for your vengeful meal. The alternative though, when dealing with a spacefaring culture, is to do a colony drop instead, which is where you substitute dragging an asteroid onto a long trip to an enemy world, and instead grab any of their larger space orbitals like an O'Neill cylinder and deorbit it onto the world below. An O'Neill cylinder would generally mass several gigatons and would come crashing down with more than its TNT equivalent, as TNT only has about 4 gigajoules of explosive energy per ton, while a ton of matter falling from Earth's orbit at about 8 kilometers per second will have more like 32, which is 8 times as much. So essentially you can quote something falling from orbit as being several times its actual mass and explosives, and in this case, an O'Neill cylinder would impact on some spot below with 1,000 times the energy of the Tsar Bomba. Given that a civilization might have many thousands of stations that size and larger in orbit, and far more smaller ones, an attacker might be able to set off a major Kessler syndrome event, wrecking those orbitals and dropping large chunks of them all over the world below, dwarfing classic nuclear Armageddon. We see this in David Weber's military sci-fi series Honor Harrington, where a big chunk of a 3,000-ton orbital shipyard crashes onto a city, killing millions. At a smaller scale, we see this done with satellites, where in the modern fantasy series The Dresden Files, they drop a decommissioned satellite on an enemy villain's hometown, blowing him and his goons up. Plus civilians, I assume. Before we leave the topic of more conventional weapons, it should be noted that a superweapon might save on power input required by taking advantage of existing sources. For instance, we explain the butterfly effect by noting that the beating of a butterfly's wings in China might affect the course of an Atlantic hurricane down the road, and while an extreme case, a very good knowledge of weather modeling might let you use very minimal and hard-to-detect efforts to steer a future storm as it develops to ransack an enemy's capital. On a grander scale, you could set off a storm on the sun's surface to blow an immense coronal mass ejection out at the right time and place to hit the target planet. It's a reminder that subtle and clever use of force can be better than raw might, though we must also remember that in any situation where your enemy has rough parity of abilities, they probably can monitor weather patterns and sunstorms fairly well, and also notice any heavy effort to alter them. If you can be more subtle than your enemy, you might be able to outfox them, though trickery has a way of weaving webs so tangled that you can snare yourself in them. In the end, a lot can be said for heavy and direct use of force. That's the first rule of warfare after all. If brute force isn't working, you're just not using enough of it. Still, we have another option that incorporates both brute force and a modicum of stealth, subtlety, and cleverness. Relativistic kill missiles are the ultimate in raw kinetic brute force, large missiles with simple guidance packages launched from afar that need no explosive warhead, not even a nuclear antimatter, because their raw kinetic energy already exceeds what a bomb, fission, fusion, or antimatter would hold. Though you may pack it with antimatter to give it extra maneuverability, it is a great and simple rocket fuel and it does add a little extra punch. Indeed, antimatter is the only known rocket fuel besides Kugelblitz black holes that can actually accelerate at LKM. Typically, we assume that it will be pushed up to speed by a powerful laser, which can push on the LKM for many days, and transfer all the beam's energy over that time into kinetic energy, which the LKM now has, and which it can deliver in total in a mere instant by ramming into something at near light speed. Indeed, this is a better approach than just using a big star-powered laser for interstellar attacks, or a Nyko-Dyson beam or stud laser, as you can skip all the issue of focusing on a target light years away and having to keep a beam on target for days in favor of putting that into individual RKMs. Or multiple, which is where the RKM really excels. It can break itself up into several smaller projectiles right before impact to spread itself around, but you can also arrange for volleys of RKMs. For instance, if I really want to hammer Earth, I want my RKMs to arrive over at least a 12-hour period so it rotates around to the undamaged side, but I can arrange my RKMs to arrive together or strung out. Consider, I can push one up to 97% of light speed, the next to 98%, the next to 99%, or so on, so that I'm using my pushing laser, matter beam, or electromagnetic catapult over many weeks or even years to sling projectiles that will arrive simultaneously or at the spacing of my choice, and deliver all that energy in an instant. And while they coast through space, having been accelerated light years away, they aren't actually invisible, but they are very tiny compared to an asteroid. They are now moving so fast that a radar that might pick them up a light hour away might give you less than a minute between when you get the return signal alerting you of the threat and when the impact occurs, and trying to pick up some skinny black metal mega bullet, maybe a few meters across and several long, moving at 99% of light speed through the vacuum of space, is no easy trick. One other advantage is you can abort an attack, detonating them or moving them off course, as you could have a forward observer or even a small command ship trailing shortly behind who could give an abort code. You cannot do that with a laser. Once it is fired, the light will arrive, and as fast as any warning signal you might send, so RKMs allow some options for later mercy as well as coercion. Surrender or die, the missiles arrive tomorrow. Incidentally, for folks wondering about the effectiveness of this superweapon against a non-planet target like a Dyson swarm, yes, it is diminished, but at the same time the RKMs can break apart sooner and spread out more like a shotgun blast to the entire system, potentially distributed over a year or more, like some brutal relativistic kill cloud. That sort of thing is going to cause a navigational hazard like a cone spreading out from that system for a broad swath of the galaxy. So like a lot of superweapons, you need to contemplate unintended collateral damage that might also bring thus far unaligned empires into the fight against you, or scare the cowards into line. Needless to say, this can be scaled up to wreck whole galaxies, and since the main shot will be moving far faster than the escape velocity of that galaxy, it will pass through into the wider void, leaving the place colonizable afterward. I will call this a Category 7 superweapon at this stage, again fairly arbitrarily, but we'll say that 8 is a galactic group killer, 9 is a galactic supercluster killer, and 10 is able to take out a Hubble volume or the observable universe. Jumping a bit ahead, but a Category 6 superweapon might be artificially setting off a supernova to take out several neighboring systems. There are any number of sci-fi settings that have used this trick, the two best known being Star Trek, where the plotline of the film Generations features artificially blowing up stars, and Star Wars, with a number of supernova-based weapons in the Legend setting, from Sith superpowers to the small spacecraft the Sun Crusher. When it comes to superweapons, few fictional settings have as many as Star Wars does, from Death Stars to thought bombs to Sith Lords who can cause coronal mass ejections to take out enemy spaceships pursuing them. We see that trick used by Worf in Star Trek The Next Generation 2 during the Klingon Civil War, and also against the Borg later in the series. As is often the case with this sort of weapon of opportunity, much like dropping a boulder on someone in an ambush, a lot depends on getting the person there. More so with supernovae, as while they are very fast explosions, they are the final moment on a process of fusion taking millions of years. Methods for setting one off have been proposed. You could launch 2 large iron slugs, at least large asteroid mass, from different directions, timed to intersect at the star's core. Hot as stars are, they actually take quite a while to melt large objects, and planets might orbit inside red giants for very long times before being burned up. so the slugs would intersect in the center, giving a large initiating blast, while poisoning the fusion reaction with ion and initiating the blast. This trick is used in the Barbaverse book series by Dennis E. Taylor, and should work on lower mass stars. This is easier in some ways with white dwarfs, which can go supernova when sufficient new matter is added, though of course adding 1% to some neo-supernova white dwarf's mass still means hundreds of Earths worth of new matter, not exactly easy to move. We might also really scale this effect up by reigniting active galactic nuclei or dumping whole stars into a galaxy's central black hole, potentially releasing galaxy-sterilizing levels of radiation in a big blast, rolling at a light speed from the core. Larry Niven's Known Space series features that event, and the well-known Ringworld megastructure comes from that setting, and was built as something like a galactic Noah's Ark. Smaller-scale events using various regular or medium-sized black holes of several solar masses to several thousand, pumped with several solar masses of rapidly infalling new matter, could be used to create hypernova, able to wreck large pockets of interstellar space in a sphere around the target, or as polar jets, striking out as long cones but even further. This is where we can start talking about edge of science options, as you might be able to dump matter into a star by wormhole, or on the flip side you dump one mouth of a wormhole in orbit of a star, or even in one, and use the other mouth as a portable flamethrower to torch planets or propel ships as its rocket thrust, such as moving and maneuvering the weapon's platform itself. This is a superweapon used to take out a meeting of a powerful galaxy-spanning faction in the novel House of Suns by Alastair Reynolds, which also shows supernova defense methods, like ringing a star in a cluster of tilted and perfectly reflective thin ring worlds. We can also dump a neutron star into a gas giant. After all, a wormhole mouth only needs to be a handful of kilometers wide to suck in a neutron star, as opposed to many thousands or millions for white dwarfs or normal stars. As we saw in our episode Weaponizing Black Holes, shooting a black hole into something isn't the superweapon sci-fi often shows us. A micro black hole mostly wouldn't do anything to a star, for instance, but a neutron star certainly would if we could dump either through a wormhole or any other version of teleportation, and a superweapon might be a fairly mundane transporter like we see in Star Trek, just one able to beam nuclear bombs from your magazines into an enemy ship or bunker. The Asgard used this trick against the Wraith in Stargate Atlantis. And anything that just ignores armor or shields is arguably a superweapon, even if the payload is very mundane. After all, a simple stone arrowhead teleported into your Supreme Leader's head works wonders for changing his mind. So too, brainwashing machines represent a type of superweapon, as do any other contagious or self-replicating devices. One could even argue bits of propaganda or philosophy are superweapons. Though a giant weaponized pulsar, blowing jets of plasma or gamma rays out for light years, seems a better example, and any neutron star could be turned back into a pulsar and probably aimed. You can do parallel tricks with black holes and white dwarfs too, and we already discussed various star weaponizing options. Getting back to our neutron star example, that's also not really how wormholes under classic Einstein-Rosenbridge version works. They are expected to collapse if you put a lot more matter through one, which a neutron star would certainly qualify as, but we will assume the more classic sci-fi wormhole portal opening. Sticking a neutron star in the middle of a gas giant should cause a detonation, not a refurbished star, as we see in Kevin J. Anderson's Saga of the Seven Suns, which is a little loose with its science, but does have a nice mix of space opera classic and big-scale superweapons. One of those is automated motorless robots that can be mass manufactured, and when they can also replicate themselves or make factories to do so, we call this a berserker. Lots of machines, automated spacecraft of varying intelligence out to kill stuff. A variant of what we call a hegemonizing swarm, borrowing the term from Ian M. Banks in his Cultural series, another sci-fi gem that doesn't hesitate to show us massive scales and stellar engineering. Banks never really details the specifics here, but the implication is somewhere between the Borg from Star Trek and a paperclip maximizer or optimizer, something that pretty much goes through space turning every free bit of matter into more of itself or its desired end state, like turning everything into paperclips, or taking every rock apart into its constituent elements to make everything into huge collections of sorted metal ingots awaiting usage. You could do that to stars too, not just planets, or directly something more useful like war machines or space habitats. One can make the argument that any interstellar species moving out from its homeworld is basically acting as a hegemonizing swarm, just with various tightness to its curve of standardization and accepted outliers, or mutant peoples and cultures. Of course, one can argue the ultimate superweapon is intelligence itself, and that while converting an entire star into a massive war engine able to rain RKMs and mega lasers across the galaxy, converting a star into a single massive computer mind, what we call a MATRIOSHKA brain, is actually way more dangerous. We don't know what the hard limits on physics are, but odds are good that such a mind would quickly find them, and that might give it access to not only some reality-bending weapons, but the brains to utilize them to terrifying effect. Those might include surprising options like being able to play with fundamental physical forces, locally altering them to be stronger or weaker, or even turning them off. Even a fairly small increase in the gravitational constant of the universe would cause stars to implode very quickly, or cause gas giants like Jupiter to become second suns, which would be both a magnificent tool for building great wonders or a weapon for wrecking them. A sudden decrease in gravitational strength could circumvent the energy requirements for vaporizing planets too, causing existing ones with molten cores to fall apart, or causing stars to explode under their own immense heat, no longer restrained by gravity. Indeed, we might imagine a bomb that caused a target star to supernova by higher gravity and use the energy from that to power a galaxy-wide drop, or an increase in the gravitational constant, taking a whole galaxy apart. Or the equivalent of a bomb-pumped laser, which normally is when we set off a nuke and use it to power a fast laser blast inside a cavity in microseconds before it vaporizes it, in this case being aimed at a distant target star or galaxy. We could do similar with alterations to other forces and fields, such as shutting down electromagnetism and the forces that bind neighboring atoms to hold together as molecules, like the Molecular Disruptor Device or MD, or Little Doctor from Orson Scott Card's novel Ender's Game, which uses that effect to further power itself, making it weak against smaller objects, but can chain react if ships in a fleet get too close, and can blow up entire planets just as easily. Shutting off the nuclear forces, like gluons which hold atomic nuclei together, could be even more devastating, and the ability to play with that might not just allow one to mass-produce antimatter or even convert matter directly into energy or other types of matter, but could risk, for lack of a better word, a puncture in the false vacuum of reality. It is the current view of physics, or most physicists anyway, that normal space, even when empty of matter and radiation, still bubbles and seethes with various waves and particles popping in and out of existence constantly. These last for only the tiniest increment of time, literally. They can be viewed as almost an accounting error of the universe, but the basic effect of so many of them doing it constantly as just a tiny, or maybe not so tiny, constant energy to an area, making it not a true vacuum, or a false vacuum. The ability to manipulate that and derive power from it is the basic concept of vacuum energy or zero-point energy, and we've discussed that more elsewhere, but it would make for a potent power source and weapon too. And if you could shut that off or suppress it, you would then have a true vacuum, and potentially an expanding collapse of the false vacuum. We think that we would essentially delete the universe there in an expanding sphere, but one thankfully that would move out at the speed of light. So while the perpetrator of civilization is toast, neighboring galaxies have millions of years, and most of the universe would be outside of its spread, much as light emitted from any place nowadays will not reach any of the places where Hubble expansion has already reached light speed or greater, the cosmological event horizon. Something like that could also have the opposite effect, instead setting off a new Big Bang in an area, blowing its way into the universe at light speed, and wrecking everything in its wake with a mix of super-fast matter and crunched-up spacetime. The ability to warp spacetime is also very potent, as a star suddenly taking up half the volume it used to is going to blow itself to bits, and the effect on planets or people would be fatal too. Ripping space-time up or increasing the rate of dark energy, possibly setting off a big rip scenario locally or universe-wide, would definitely all qualify as superweapons. So would the ability to create closed time-like curves, which are a restrained and less paradox-prone version of time travel, where you can, conceptually, build a machine that lets you reset back to when you turned it on the first time. There are a lot of ways to use that to your advantage, not least of which is infinite save states, so to speak. Of course, if time travel is on the table, it might mean the ability to go arbitrarily far back in time, and we looked at the possible consequences and results of that in our episode Time Wars, and more in its recent sequel, Multiverse Warfare and Quantum Mania. But just the ability to send one single atom back in time, or crush one Planck volume of space, can potentially delete entire civilizations, or entire superclusters if you manage to hit early enough, back during or before the inflationary epoch moments after the Big Bang. Great power source too, if you can do the portal trick we discussed with wormholes earlier, only to an early and energy-dense era of the universe rather than opening a portal into a star. The primal energy back when the universe was denser than atomic nuclei can definitely feed some serious engines for pushing ships, powering empires, or blowing them to smithereens. And of course, unless that is coming from a younger alternate universe, not your own, the empire blown to smithereens might be yours, or all of them in your universe, while you drain the past dry of energy and utterly wreck your timeline from moment zero. One could imagine that as a pretty good way to start a war between universes though, tapping them for power and tearing up their timelines, or the same for multiverse brains in string theory. We see something like that in Isaac Asimov's epic novel The Gods Themselves, and when it comes to superweapons of this sort of scale, that might be a very appropriate name for both the wielder and target of such immense superweapons. So it's Sci-Fi Sunday here on SFIA, on YouTube and most of our other platforms, but on Nebula, we just had our episode Life on Giant Moons come out, early like all our episodes on Nebula, which you can join if you don't want to wait till Thursday. But we also have to have bonus content there, from extended editions to entire exclusive short or even full-length episodes. And we just had one come out a couple of days ago, Colonizing Binary Stars. So if you want to catch exclusive content like that, along with seeing all of our episodes a few days early and ad-free, including no sponsor reads, you can click the link in the episode description, go.nebula.tv/IsaacArthur. That lets you see all the exclusives like Colonizing Binary Stars, or full-length episodes like Planets vs. Megastructures, or our entire Coexistence with Aliens series. And again, it's all early and uninterrupted by ads, so you can enjoy the episodes as intended. Nebula is a streaming service started by creators for creators and their audiences, and has grown to be the largest creator-owned streaming service. No YouTube algorithms penalizing content or dumping badly matched commercials on you, and using my link and discount, it's available now for just over $2.50 a month, less than the price of the drink or snack you might have been enjoying during the episode. And it goes to supporting new content from myself and other creators, like our new feature, Nebula Classes, so it's 2 for the price of 1. When you sign up at my link, go.nebula.tv/IsaacArthur, and use my code, IsaacArthur, you not only get access to all the great stuff Nebula offers, plus now classes, you'll also be directly supporting the show. Again, to see SFIA early, ad-free, and with all the exclusive content, go to go.nebula.tv/IsaacArthur. So that wraps us up for today, but we'll be back in a few days with our look at life on giant moons, ones nearly as big as Earth itself or even larger, and how life might arise on such worlds and how we might colonize them. And a week from now, we'll be having our monthly livestream Q&A, Sunday, April 23rd at 4 p.m. Eastern Time. Then we'll be returning to Earth and the near future to talk about smart cities and the future of automation in urban environments and how that will change them. Then we'll jump into May with a return to the Fermi Paradox to discuss Dysonian SETI and how we might find Kardashev 2 civilizations. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon, and if you want to donate and help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service, Nebula, at go.nebula.tv/IsaacArthur. As always, thanks for watching, and have a great week.